Hello guys, welcome to our class. We are still discussing kinetic molecular theory of gases, but for today we are going to be looking at latent heat and change of states. Latent heat and change of states. So guys, if you have not subscribed to this channel, or if this is your first time or visiting this channel, you are welcome and we appreciate you. Please subscribe to our channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, you can reach us via the WhatsApp number that is showing right on your screen. This is Normal Science Tutors Online. I remain Otobo Michael, and our aim here is to make physics as simple as possible for you. So if you have any challenge, please you can reach us through the WhatsApp number. We also want you to give us a like by giving us a thumbs up. That finger, that hand that is raised up, click on it, give us a like. Then you can place your comment on the comment section of this video. Right, so if you have gotten your writing materials ready, please let's go to the class for today. We are looking at latent heat and change of state. Latent heat and change of states. Latent heat and change of state. So when a solid is heated slowly, a temperature is reached where the solid ice starts to melt. Now you discover that as the ice melts, the temperature remains constant. The further heat supplied is only used to change the state of ice to liquid. This is what actually happens. Then similarly, when a liquid is heated up to the boiling point, the temperature remains constant while the liquid continues to boil. The further heat supplied is used to change the liquid to gas without changing in temperature. Okay, so when you are ice, you can have ice at minus 10 degrees, minus 4 degrees, and all that. But the moment you begin to apply heat to the ice, once it gets to 0 degree, the ice will begin to melt. And as the ice is melting, you find out that the temperature will remain constant. It will not increase again until after the ice has melted totally. And same thing too, when you begin to heat water at 0 degree, the temperature will rise until it gets to 100 degrees centigrade. At 100 degrees centigrade, whether you apply more heat to or whatever, the water will continue to boil. The only thing you'll be observing is that the water will start to dry up, which means the liquid water is being converted to gas at constant temperature. Okay, so also conversely, when a liquid is cooled up to the freezing point, it changes from liquid to solid at the same temperature. Like water now, when you cool water from maybe say 10 degrees to 0 degree, at 0 degrees centigrade, the water will begin to form solid. Any more reduction of heat, it will not show. It will only be forming more solid ice at the same temperature. Okay, so this heat that you don't see, that does not show on the thermometer, that heat that does not show on the thermometer, that is constant, that does not indicate in your thermometer, is called latent heat. Latent means hidden, something that is hidden. Latent heat. So that heat that does not show, that is undetected, is called latent heat. So latent heat is required to change the state of a substance at constant temperature and pressure. The heat that is required to change the state of a substance at constant temperature and pressure is known as latent heat. Okay, so having known what latent heat, having known that latent heat is hidden heat that cannot be detected by a thermometer, what is specific latent heat of fusion? You know that fusion is melting. So specific latent heat of fusion is the heat required to convert a unit mass of a solid at the melting point to its liquid form without a change in temperature, and the unit is joule per kg. joule per kg. That is the unit of latent heat, specific latent heat. So you can write it in the form of equation that quantity of heat is equals to mass times specific latent heat, and that is Q is equals to ml, where L is specific latent heat. So Q is quantity of heat required, and M is mass of the substance, L is latent heat or specific latent heat. And so if you make L the subject of this equation, you have that L equals to Q over M. Okay, so Q is in joule and M is in kg. That is why the unit is equals to joule per kg. Joule per kg. Is that okay? So quantity of heat is equals to mass times latent heat, specific latent heat. Okay, so please take note of that equation and this one, because we'll use them later to solve some problems. Alright, so that is latent heat. Now we'll look at melting and cooling curve. Based on what we just discussed before, we'll first of all look at a latent heat by electrical method. We know that quantity of electrical energy is given by electrical energy is given by, or from our previous lecture, is given by I Vt, where I is current, V is potential difference, and T is time. And this is also equal to power times time. So from quantity of heat is equals to ml. For electrical heat energy, you can write that I Vt is equals to ml, and that L is equals to IVT all over m, or from PT, power times time, equals to ml, mass times specific latent heat. Latent heat equals to power times time all over mass. So depending on the variables that are given in a particular problem, you should know which of these equations to apply. Okay, so this is latent heat from electrical method. It's latent heat from electrical method. So take note of these equations, because you can apply them to solve some problems that you might come across. All right, so thanks. Let's move on. So I mentioned melting and cooling curve just now. Remember we discussed in the previous slide, we talked about melting, right? We talked about melting, and we said that when heat is applied to a solid, the temperature will begin to rise gradually until it gets to the melting point. At the melting point, the temperature will be constant. Then when the solid has melted totally to a liquid, the further it will apply will begin to increase the temperature on the temperature gets to maybe the boiling point of the liquid. At that point, the temperature will now become constant. Then you have boiling in that curve, or in that plateau. You have boiling in that plateau. So this is called the melting curve, and the point at which the temperature remains constant, where you have this plateau, is known as the melting point. Then this one is cooling. As temperature is reduced, the liquid will start to freeze gradually until you get to the freezing point. At the freezing point, the temperature will be constant. When the liquid has frozen totally, it becomes a total solid, and the temperature will also continue to drop. Temperature, so at the point of freezing, the temperature remains constant. at the point of freezing, like for ice, the freezing point is 0 degrees centigrade. So at this point, as the water is forming more ice, the temperature will remain constant until the whole liquid has become solid ice. Then the more you remove heat, the temperature of the solid or of the ice block will start to reduce further. Okay, so this is a cooling curve. This is the cooling curve. This one is melting curve, and then this is a freezing or cooling curve. Okay, so what are some of the observations from water that is freezing? Because water expands when frozen, it causes glass bottles to crack. We've discussed it before. Then ice is less dense than water, and hence it flows in water with about 9.5 of its volume submerged. Yes, this is something that you can experiment. Just throw ice inside water, you will see that the ice will be floating with part of it submerged while another part of it is on top of the water. Ice contrasts on melting, and that is true, right? Just like when water freezes, it will expand. When ice is melting, it will do what? Contracts. So with this simple phenomena, you need to just take note of them. These are just for your own understanding and for deeper knowledge. Okay, so let's move to another concept. Effect of pressure and impurities on freezing point. So we just discussed freezing point now. So what are the effects of pressure and impurities on freezing point? Increase in pressure lowers melting point of ice or the freezing point of water. This applies to substances that expand on freezing or solidifying. So water expand when it freezes. So which means that when you increase the pressure, it will lower their freezing point or melting point. Impurities also lowers melting point of pure solids. Okay, so if you put impurities on a pure solid, it will lower their melting point. Regulation is a result of effect of pressure on melting ice. So the fourth point is that when pressure is applied to ice, it melts, and when the pressure is removed, it freezes. This is known as regulation. Now, although you cannot perform this experiment, but if you can have a block of ice, the experiment is that if you have a block of ice, you put a tiny wire across the ice, then you put two weights on the two sides, then allow it to rest on the block of ice. You find out that gradually the wire will be cutting through the ice. As the wire falls off the ice, you see that the ice will not cut into two. The ice will remain the same. So that is the effect of regulation. As the wire is resting on the ice, it is exerting pressure on the ice. And because it is exerting pressure on the ice, it is lowering the melting point of the ice. And because of that, the ice that is directly under the wire will start to melt, and it will allow the wire to pass through. While the liquid that forms above will now, because of reduced pressure, it will freeze back. So that as the wire passes through the ice beneath the wire will be melting, while the one above it will be, the liquid that is coming out will be freezing. And that is why the wire will pass through the ice without the ice cutting into two. So that observation or that phenomena is called regulation. Okay, that phenomena is called regulation. All right, so these are the effects of pressure and impurities on freezing points. Let's look at another concept: latent heat of vaporization. Latent heat of vaporization. So in our previous discussion, we mentioned vaporization, and we said that vaporization is a process in which a substance changes from liquid to gaseous state. Is that okay? So, and the temperature that this occur is known as boiling point. So we have what is called latent heat of vaporization. The latent heat of evaporation of a substance is the quantity of heat required to change a unit mass of the substance from its liquid at the boiling point to vapor without a change in temperature. And based on our equation before, we have that quantity of heat is equals to mass times latent heat of vaporization. And if the heat supplied is from an electric source, then we have IVT, which is quantity of heat is equals to mass times latent heat of vaporization. And from this equation, we can have that latent heat of vaporization is equals to either Q, quantity of heat all over mass, or latent heat from the second equation is equals to IVT all over mass. So depending on what you are asked, you know which of this equation to do what to apply. Now there's a phenomenon that we also experience on a daily basis that I need to bring to your attention, and that is why steam causes more severe burns than boiling water. Why steam causes more severe burns than boiling water. So why does this happen? Or have you experienced this kind of phenomena before? If you have not, you should, I will not say you should go and burn yourself, but this is what actually happened. Steam causes more burn than water. Is that okay? So why does it happen? This is why it happens. Steam burns are more severe than boiling water because phase change requires more energy than just temperature change. Okay, you know, when you boil water from 0 degree to 100 degree, that one is just temperature change. But for the liquid boiling water to become steam, that one is phase change. Okay, so the energy required for water to go from liquid to gas phase is called heat of vaporization. At the boiling temperature of 0 degrees centigrade, particles of steam acquire more energy than the particles of the boiling water, as they have absorbed extra energy in the form of latent heat of vaporization to go from liquid to gas phase. Also, when the steam hits the skin, a lot of energy is released, and this energy is in the form of latent heat of condensation because the steam will condense back to liquid. So because of this happening, this is why steam causes more burn than boiling water. Okay, so simply put is that, remember, as I said, for water to rise, from the temperature of water to rise from 0 to 100 degree is different. That one is called temperature change, and the quantity of heat required for that one is different. Then the heat also, there's another heat that is required to convert this boiling liquid to steam. That one is heat of vaporization. So which means that for a liquid to to be converted from liquid state to gaseous state, it means that water will have two types of energy. One, the energy required to convert it to the energy required to boil the water. Okay, the energy required to boil the water, then the energy required to convert the boiling water to steam, which is latent heat of vaporization. So steam has latent heat of vaporization plus steam has latent heat of vaporization plus the energy required to convert the water from 0 degree to 100 degrees centigrade. Is that okay? So steam has these two energy. So that is why the energy that is released by steam is more than the energy released by water, by boiling water. Boiling water, the quantity of heat is just mc theta. Why steam has the quantity of heat for steam is equal to ml plus mc theta. So once you just understand this, once you understand that steam, for steam, for steam, energy is equals to ml plus mc theta. That is what you should understand. Why for ordinary boiling water is equals to the energy it has just mc theta. So if you compare these two, which one has more energy? Is the steam. So that is why steam burn more than boiling water. Once you understand this simple concept, I think it is easier. Steam, the energy of steam is mass times latent heat of vaporization plus mass times specific capacity times change in temperature. Why for boiling water is just mass times specific capacity times change in temperature. Finish. So if you understand this, life is easy for you. Okay. So sometimes they give this question in your examinations. That's why I have to bring it up. Okay. So thanks. Let's move on to another concept. Evaporation. Okay, so we've talked about vaporization. We mentioned evaporation before, so it's just a repetition so that to drive home to have a deeper understanding. Okay, evaporation is a process by which a liquid changes spontaneously into vapor below its boiling point. That's what we said before, that evaporation takes place at all temperatures. Now, there are some factors that affect evaporation. One of them is temperature. Increase in temperature increases the rate of evaporation, definitely. Pressure. The higher the pressure, the slower the evaporation. So less pressure, higher evaporation. Higher pressure, lower evaporation. Wind and dryness of air. The more the wind, the more the wind, the more the rate of evaporation. So wind and dryness of air increases the rate of evaporation. Nature of the liquid. Liquid with low boiling point evaporates faster. You know that one now. If you put ethanol in your hand, it will evaporate very fast. Is that okay? So liquid with low boiling point evaporates faster. Area of liquid exposed. The more surface of liquid exposed, the greater the rate of evaporation. This one is also everyday phenomenon that you experience. The more the surface area that is exposed, the greater the rate of evaporation. That is why when you put your clothes outside to dry, when the weather is windy, when wind is blowing, you find out that your clothes will dry very fast. Or when the air is dry, like during harmattan season, you see the difference. Once you put your clothes outside during an harmattan season, your clothes will just dry in very short time. Unlike during normal weather, or during cold weather, or during rainy weather. You know, during rainy periods, clothes does not dry easily, but during harmattan, everything will dry very quickly because of the dryness of the air and the presence of wind. Okay, so these are some of the factors that affects evaporation. You want to take note of all this, or you take note of all this. It's for you to take note of factors that affect evaporation. Okay, kinetic molecular theory for evaporation. So most of the concept in heat energy, they are always explained using the kinetic molecular theory molecular theory. So according to the molecular theory of matter, a liquid consists of molecules that are in constant motion, and the average kinetic or the average velocity and kinetic energy is related to the temperature of the liquid. So when the temperature of the liquid is increased, the liquid molecules will gain more kinetic energy. So because of this, the molecules near the surface of the liquid will gain enough energy and escape from the force of attraction of other molecules in the liquid to become vapor. So higher temperatures increases the velocity of all the molecules, thus allowing more molecules to escape from the surface and hence increasing rate of evaporation. So the more the temperature, the more the rate of evaporation, because more of the molecules of the liquid, they will gain more velocities, and because of that they will escape from the force of attraction on the surface of the molecules. They will escape and become vapor. Is that okay? So that is evaporation by the kinetic molecular theory of matter. Now, why does evaporation cause cooling? This is another concept that is explained also by the kinetic molecular theory of matter. Now, you can easily experience this when you put methylated spirit on your hands, or when you use it to touch the back of your skin. So when methylated spirit or ethanol is spilled over any part of the body, a cooling effect is felt. The body becomes cooler because the latent heat required to convert the liquid to vapor state is extracted from the liquid or any object in contact with it. So what that means is that the latent heat of evaporation, okay, the latent heat of evaporation of the methanol or the methylated spirit from your hand is absorbed or taken from your hand. The extraction of latent heat from the liquid or liquid or body in contact with it leads to a fall in temperature. Also, when the human body is perspiring, there's a cooling effect because of the sweat that is evaporating from the surface of the skin. This is because the latent heat of evaporation is extracted from the body, hence the cooling effect felt. Another phenomenon that you need to take note of is this one. Okay, water stored in earthen pot gets cooler than the one stored, this is than the one stored in a plastic container. Why? This is because evaporation takes place through the pores on the earthen pot. Okay, you know an earthen pot where, these days many children don't go to the village, so they might not know what is an earthen pot. But an earthen pot is made with clay. So within the pot there are pores that you cannot see physically, but when you put a liquid on the earthen pot and you place it outside, the next morning you will see that there's something like sweat on the body of the earthen pot. Is that okay? So the earthen pot stores water and it makes the water inside the earthen pot to be cooled because of this phenomenon of evaporation causes cooling. Because of the evaporation that takes place between the pores, through the pores in the earthen pot, the water that is inside the pot will become cooler than water that is stored in plastic outside. Okay, so this is another phenomenon that we experience regarding evaporation causing cooling. Now, according to the kinetic molecular theory of matter, the molecules of a liquid possesses average kinetic energy and velocity which increases with temperature. Molecules near the surface which are moving faster escape from the attraction of their neighboring molecules and out of the liquid. Thus, the liquid loses most of its energetic molecules, leaving behind less energetic molecules. The average kinetic energy of the remaining molecules is thus reduced. This results in lowering of the temperature of the liquid. This principle is applied in refrigerators. So this principle of evaporation causing cooling is what is applied in your refrigerator. The gas that is inside your refrigerator will take latent heat from the refrigerator as it is working, as the gas is flowing around. It will extract heat, right? It will extract it. As it is extracting the heat, your freezer or your fridge will be getting cooler. Your freezer or your fridge will be getting cooler. So this is the reasons why Evaporation causes cooling. Evaporation causes cooling because the latent heat of vaporization is taken from the surface that is in contact with the liquid. So if it is in your hands, if you put ethanol in your palm, the ethanol will extract the latent heat of evaporation from your hands, just lowering the temperature of the molecules of your palm. As the temperature is lowering, it is as it is extracting the heat from your hand, it is lowering the temperature of the molecules in your hand. That is why you have that cooling effect on your palm or on your skin. Is that okay? So that is why evaporation causes cooling. Boiling. Now, when water is heated in a container, the temperature rises and the liquid evaporates. That is normal. As the heating continues, the temperature also continues to rise until the water begins to boil. Now, during boiling, bubbles of air form inside the liquid and rise to the surface and burst. And that is what you see as boiling. It is the bubbles of air that forms inside the liquid that rise to the surface and burst. So as we are applying more heat, more of the molecules will be rising up. The more of the air bubble will rise up and burst continuously. And that's why you have the bubbling effect when water is boiling. So the water that is boiling, it is the molecules of the liquid that are rising up. They will burst, they will rise and they will burst. And that is what leads to those bubbles you see. So the temperature of the liquid remains constant during boiling, and this temperature is known as the boiling point of the liquid. So difference between boiling and evaporation. Boiling takes place at a particular temperature, but evaporation takes place at all temperatures. We have discussed this before. Boiling does not cause cooling, but evaporation causes cooling. Boiling occurs in every part of the liquid. Evaporation occurs only at the surface. Boiling is affected by the mass of liquid exposed. Evaporation is not affected by the mass of liquid exposed. So these are the differences between evaporation and boiling. You need to take note of that. Right? Effect of pressure on boiling. So pressure also have effect on boiling, and these are some of the experiences that we have on a daily basis. Increase in pressure at the surface of a liquid increases the boiling point of the liquid. Also, a decrease in pressure decreases the boiling point of the liquid. So, where this one is actually applied is in the pressure cooker. The pressure cooker normally increases the boiling point of the liquid that is inside the pressure cooker because it increases the pressure. And that is why the pressure cooker cooks food faster than when you are boiling it with just your ordinary pots. So the pressure cooker increases the pressure of the liquid and thus causing an increase in the boiling point of the liquid. This increased temperature is reached very fast, thus reducing cooking time. Okay, so that is why the pressure cooker is used. So if you are asking a question, you should know that the pressure cooker increases pressure in the liquid that is contained in it, and this leads to increase in boiling point of the liquid. And because of this increase in boiling point, it will make the whatever that is in it to cook very fast because there will be increase in temperature. Okay, also presence of impurities or dissolved substances in a liquid raises boiling point but lowers freezing point. We discussed this before that impurities lowers freezing points, but it increases boiling point. Sublimation. Okay, I just brought this up. It's part of change of state. Under certain condition, a solid can change from solid to vapor or gas without passing through the liquid phase. This process is called sublimation, and this happens mostly in iodine crystals. So the process by which a solid changes to a gas without passing through the liquid phase is known as sublimation. Okay, so take note of all these phenomena that we have discussed or concept that we have discussed. Okay, so far we have discussed change of state, and in this particular slide, we'll be looking at the kinetic molecular theory of change of states. According to the kinetic molecular theory, the molecules of the solid vibrate about a mean position. So when the temperature of the solid increases, the molecules gain greater kinetic energy and vibrate further away from their mean position, thus weakening the intermolecular forces binding them together. At a certain maximum temperature, the molecule gains maximum kinetic energy. This temperature is the melting point. Any further heat does not increase the kinetic energy of the molecules, hence the temperature of the substance remains constant. This heat at this temperature that does not change is known as latent heat of fusion. We mentioned this before. All what I'm saying now is what we have discussed before. Now, for the liquid to change to gas, heat is added. This heat increases the velocities and kinetic energy of the molecules at the surface. This does overcome the weak binding force holding them together, holding them to other molecules in the liquid, hence they escape in a process called evaporation. At a certain maximum temperature, the average speed or kinetic energy of the molecule is great enough for all the molecules to break loose and be independent of each other and exist as a gas. Okay, so this is the kinetic molecular theory of change of states. Most of the grammar might be a little bit difficult, but what you want to understand here is that as heat is applied to a solid, the molecules of the solid, they will begin to vibrate. They will gain kinetic energy. They will gain average kinetic energy. They begin to vibrate. At a point in time, the intermolecular forces that is holding the molecules together will be weakened. The intermolecular forces will be weakened, and at a certain maximum temperature, when the molecules have gained maximum kinetic energy, the molecules will begin to melt. Any further heating will not increase the kinetic energy of the molecules, hence the temperature will remain constant. And this temperature is the temperature that is known as a melting point, and the heat that is experienced at that time is known as latent heat of fusion. Latent heat of fusion. Now, for a liquid to change to gas, heat is also applied to the liquid. As heat is applied to the liquid, the velocity and the kinetic energy of the molecules will also begin to increase. And as this is increasing, the molecules will now overcome the weak binding force that are holding them together in the liquid and begin to escape to the surface. As the temperature is increasing, more of the molecules will gain more kinetic energy and they will continue to escape to the surface as gas. Okay, so I'll try to break it down for your simple understanding, but please read more so that you see get deeper understanding of this kinetic molecular theory of change of states. Okay, so thank you so much for your time. We appreciate you, and we hope that we are making some impact in your knowledge of physics. Is that okay? So before we end this class, please, if you have not subscribed, please subscribe to this channel. Click on the notification bell so that when we will upload a new video, YouTube will notify you. We appreciate you so much for your time. Continue to visit our channel, give us a like, give us a thumbs up, reach us through the WhatsApp number that's showing on your screen. We hope to look at all your comments. Place your comment on the comment section. We want to hear from you. Place your comment, tell us how you are feeling. Just discuss any issue you have with physics. We are here to help you. Is that okay? Invite your friends to come and enjoy this physics class. Thank you so much. We appreciate you. We hope to see you in our next class. Thanks.